Hi everybody, in this video we're going to be talking about factoring and continuing factoring. We're going to do pages 9 through 13 from your handbook. And so we're gradually getting our steps in order to be able to factor trinomials. In the last video we were factoring 4-term polynomials. Trinomials means that there's 3 terms, and that's the ones you're going to come across the most in the future. So part 1 of this series of pages is actually going the other direction. You already are working with factored versions of polynomials and you're multiplying them back out. So real quick, let me remind you, or actually just explain the words. I've been saying factor, but basically when you talk about factoring, you're breaking things apart in terms of multiplication. So just a really quick example with a number, if I said something like factor the number 6, what that means, if I use the word factor, is that I want you to say what times what. How do I multiply numbers to make 6? What times what makes 6? And we would know that that's 2 times 3. If I said factor 8, well, that can be 4 times 2, or it could be 8 times 1. And so factor means to break apart with multiplication. Now when we have polynomials, it just looks a little different. You're going to be starting with trinomials that don't have multiplication separating the factors. So this is the opposite of what we're doing. This is actually the result that we're going to end up looking for. Something times something means that it is factored. Okay, so we worked this out in a previous video, how to multiply binomials. So I'll just remind you on one of them, and then we'll pause it and you'll finish the rest of part 1. So on these ones you can use FOIL or the box method. I'm going to just FOIL by talking it out with you. X times x is x squared. X times 4 is 4x. And then I'm going to add 3 times x, which is 3x. So I'm going to add 4x plus 3x. So that's 7x. And that's from the O and the I from FOILing, or the middle 2 terms from the box method. And then last times last is 3 times 4, so that's 12. Okay, so pause the video and finish part 1. Okay, so part 1, we finished this here. Hopefully you've got these results. Each of them, when you FOILed or used the box, each of these binomials getting multiplied, the middle terms combined, so there's only a total of 3 terms for each of these answers. Now, this is what a trinomial is. So that's what I was mentioning before. Each of these answers is a trinomial. 3 terms that make up a polynomial is a trinomial. And so the goal of this process, the whole goal of this video essentially, is to start with these trinomials and work our way backwards to getting these binomials being multiplied. In other words, start with a trinomial and factor it. Get it into its factored form. So that's what we're attempting here. Part 2, list all products of binomials that will result in a leading term of x squared and a constant term of negative 18. Okay, so here's an example for us. If you FOIL this out, you're going to get x times x is x squared. In the middle, you're going to get x times negative 6, which is negative 6x. I'll just put it here. You'll have a middle term of negative 6x, and then the next middle term is plus 3x, giving you a combined middle term of negative 3x. And then last times last, when you FOIL, is 3 times negative 6 is negative 18. So that's what this is talking about. So it's saying come up with these other binomials that will do the same thing, but the middle term is actually going to be different. So if we start with x squared, the only way to get x squared is x times x. And now we're thinking about, well, how do I get negative 18? We already tried 3 and negative 6, so let's try another combination. How do I get negative 18? Well, I can use negative 9 and positive 2. Okay, and let's FOIL that out real quick. So x times x is x squared. In the middle, I have x times 2, so that's 2x. And then negative 9 times x is negative 9x. So the middle term would be negative 7x. And then last times last, negative 9 times 2 is the negative 18. Let's do another one. So the only way to get x squared, again, is x times x, but I need a negative 18 again. Okay, so how about, let's go with negative 18 and positive 1. Okay, x squared, negative, let's start here. 1 times x is positive 1x. The O, that was the O from FOIL. I from FOIL, the inner, negative 18x. Okay, and if you add those up, negative 18 plus 1 is negative 17. So negative 17x. Okay, so there's still more spaces, so there must be more combinations, but it looks like we've exhausted all the numbers to get to negative 18 through multiplying. But the other combinations that we actually want is the same numbers but switch the signs in our factors. So if I work my way from the one I just did, I can also say that x plus 18 times x minus 1, when I FOIL it out, I'm going to have an x squared in the front. I will end up with a negative 18 in the back. So the middle terms, though, negative 1 times x is negative 1x. 18 times x is positive 18x. And so the middle term here is positive 17x. Similarly to this one, where you just can say x plus 9 times x minus 2. FOIL it out, x times x is x squared, negative 2 times x, inner 9 times x, and then the last, of course, is 9 times negative 2, which is negative 18. The middle term here would have been 7x. And then our final combination, x minus 3 times x plus 6. X times x is x squared, 6 times x, negative 3 times x. Middle term would be 3x, and then negative 3 times 6 is negative 18. Okay, so are all of these the possible products of binomials, all of these listed above? And then how do you know? So this you can write in your own words, but basically we came up with every single combination for how we can come up with a negative 18 by multiplying, and all of the ways to get an x squared. So x times x was x squared in all of them, but then we just used all of the combinations to possibly get negative 18 for the last term. So yes, we did in fact exhaust this list. Okay, so we're going to move on to the next page. On to page 10 now, so just flipped over page 9. If possible, match the given polynomial with the proper factorization from the table above or previous page. If not possible, write prime. Okay, so x squared plus 3x minus 18, well, we know that that would factor as a binomial with x in it and another one with x in it to get the x squared. The two numbers that multiplied to negative 18, but when we added them, we had to get the 3x. If you flip it over your page, you'll see that this came from using positive 6 and negative 3. Okay, if you want to, you can look or FOIL it out real quick. 6 times x is 6x, negative 3 times x is negative 3x, and you add those to get the middle term. So that was how this factored. This one we know was x and x to get the x squared. And then how do I get a negative 17x in the middle, but still get a negative 18 from the back when I multiplied the last two terms? Well, that was when we had a combination of 18 and 1. And it was a negative 17x. So that was when the 18 was the negative number and the 1 was the positive number. Because if you FOIL this out, you'll get negative 18x plus 1x, which is negative 17x. And the last one here, you want to think about this, and you can flip over your page. We didn't actually ever see this. How could I multiply out to get a negative 18? Which combination of numbers would multiply to make negative 18? But then when I end up adding those two terms in the middle, those two numbers, I'm going to get a 12. It's not going to work. So this one is actually considered prime. Okay, so there is not a way to factor this. So this is considered a prime polynomial or a prime trinomial because it doesn't factor. And so sometimes you'll be asked to factor polynomials, not that often, but sometimes, and the answer will be that it's prime because it does not break down. Prime, think of just like a prime number. If I said something like the number 5, 5 is prime because it doesn't break down. 6 is not prime because it does break down, it does factor. All right. Moving on, list all products of binomials that will result in leading term 3x squared and constant term 12, where the trinomial has the greatest common factor of 1. Okay, the last part after the comma is basically just saying that we don't want to have a bunch of multiples of 3 and 12. So, how do I multiply to get a 3x? There's only one way to do that. If you think about it, the only way to get 3 from multiplying is 3 times 1. So each of these factors has to have a 3x in it and a 1x in it. That is the only way when I multiply that I'm ever going to get a 3x squared. So then next, well, how do I get a 12 from there? Well, the first example was if I have a 1 times 12, I'm going to definitely get a 12. And then the middle term there was 3x times 12. So 3 times 12 is 36x. And then 1 times x is a 1x. So that's why the middle term here would have been a 37x. So how else can I get a 12? If you think about it, we did 1 and 12 here. Well, let's just use those same numbers, but watch this. Negative 1 and negative 12. If I multiply these out, I'm still going to get a positive 12 because a negative times a negative is positive. So let's FOIL this out real quick, but write down the middle term only. So 3x times x is 3x squared. Outer times outer is negative 12 times negative 3x, which is negative 36x. Inner times inner is negative 1x, giving us a middle term of negative 37x. And then last times last, negative 1 times negative 12 is positive 12. So this one did work out. Another one here. Remember we talked about it. The only way to get a 3x squared is 3x times 1x. Okay, so we know that has to go first. Okay, so how else can we get a 12? We did a 1 and 12, both ways that are possible, negatives and positives. So how else do we get 12? Well, we know that 12 is 2 times 6. Okay, but I need a positive 12. So positive 2 and positive 6. So we FOIL this out, 3x squared in the front. 6 times 3x is going to give us 18x, positive 18x. Inner times inner here is 2 times x, so plus 2x. So the middle term in this case would be 20x. And then last times last, 2 times 6 is the 12. Let's do the same idea here, but change the signs, and we're going to get a different middle term. So 3x times x, and let's use a negative 2 and a negative 6. 3x times x is 3x squared. Outer terms, negative 6 times 3x is negative 18x. Inner terms, negative 2 times x is negative 2x, which would give us a middle term of negative 20x. And then negative 2 times negative 6 is positive 12, so that one also works. Okay, let's see. We have looks like 2 more. 3x times x gives us 3x squared, but I need to multiply to get 12, and hopefully you're thinking of what's still missing here. It would be a 3 and a 4. Okay, so positive 3 and positive 4. If we FOIL this out, 3x squared, 4 times 3x is 12x. 3 times x is 3x, giving us a middle term of 15x. And then last times last, 3 times 4 is the 12. Okay, you probably know it, what the last one's going to be here. It's going to be a 3x minus 3 and a single x minus 4. Okay, and so 3x times x is 3x squared. Negative 4 times 3x is negative 12x. Negative 3 times x is negative 3x. Middle term is negative 15x. And we have positive 12 in the back. Now let's check something here. It says where the trinomial has a GCF of 1. Okay, some of these, this is actually not going to be true, and here's why. My first term had a 3, my middle terms are these listed here, and my last term has a 12. Well, 3, 12, and 15 and negative 15 all share a 3. And so what's going to happen here is these two actually don't count for what the list was asking for, just because of the last part of the sentence. So I just wanted you to be aware of that. And the way you can tell when we go back to the factored version is right here in these two factors. There is a 3 in both terms, so you can factor that out. You can share that 3 and factor it out. Instead of putting the 3 with the 3x, I could say 3x and put the 4 with it. And so the 3 would go in the next factor, x plus 3. And then very much the same, I can do the same thing with the minus signs. Instead of putting the negative 3 with the 3x, I could put the negative 4 with it. And so I'll put the x with the negative 3. What this is going to allow us to do is avoid having this greatest common factor greater than 1. We're not going to have these 3's together. So we'll FOIL this out really quick to get the middle terms. So 3x squared for the first term. 3 times 3x is 9x. 4 times x is 4x. And so that's a middle term of 13x. The last one here, and then last would be, of course, the plus 12. And then on this one, 3x squared is the first term. Negative 3 times 3x is negative 9x. And then negative 4x, and that's a middle term of negative 13x. And of course, that adds up to 12. So there was a couple more that I could add to the list. Okay, so it says on page 11, if possible, match the given polynomials with the factorization that we just figured out. If it's not possible, then the polynomial is prime. So 3x squared minus 13x plus 12, we actually found that at the end of our list just a little while ago. We know the only way to multiply to get a 3x squared is a 3x times an x. We do have to get a 12 and from the last two terms getting multiplied, but we need to multiply to get negative 13x. And so in that case, we got the negative 13x as the middle term when we put the negative 4 in with the 3x and the negative 3 in with the x. And you can check. So if you just FOIL, let me start with the O part because we know the F is going to work out. So O, negative 3 times negative 3x is negative 9x minus 4 times x. That is the negative 13x in the middle there. The middle one, the second one here, again, the only way to get a 3x squared is 3x times x. And then when do we get a 20x in the middle, but a 12 in the back? Well, remember your numbers need to multiply to make 12 in the back, but in this case they have to add up to 20 when you FOIL. And so that combination that gave us that one was when we said 3x plus 2 and x plus 6. And again, if you check, let's do the outer and inner of FOIL. 6 times 3x is 18x, plus 2 more x's is the 20x. Last one here, if you look back at our list that we just went through, 5x was not one of the middle terms, and so there is no way to factor this in such a way that you'll get 12 as the last number and 5x as the middle term from foiling this out. So there is no way to do this. So this is another example of a prime polynomial. Okay, so part 3. I want you to take a look at part 3, pause the video, read this, and see what you can come up with. Okay, did you get that they should have put 2x plus 3x minus 10? So here's the mistake that they made. They thought about, most likely, how do you multiply to get 30? And yes, negative 15 times negative 2 is 30, but when you FOIL this out, you're not going to get the middle term of negative 17x. And the reason being, basically, is because there's a 2 in the front. There's a 2x squared. If this was not 2, if this was invisible 1, we would have just, then this factorization would have worked. but we have to account for that 2 during the FOIL process. And so if you look at these factors here, x times x is 2x squared. Negative 2 times 2x is negative 20x. 3 times x is 3x. Put those together, you do in fact get that negative 17x. Alright, so the last question on this page just says, what similarities or differences do you notice through the products? And you can look at the, you can put this in your own words, look at all the examples we've done so far, and just kind of notice whatever kind of patterns you see, and it has to do with the terms getting multiplied in the back, the last 2 terms from the FOIL, but how that relates to there being a coefficient of 1 or not. Like this case, there was not a 1, there was a 2. Alright, we'll do the next page. Moving right along, we are on page 12, part 4. So list all patterns that you recognize in each area model. So this is, the area model is like the box method. And so the patterns, you can basically say this in whatever way you want, but let's just fill in the box. So we have rows here, columns here. X times x is x squared. Okay, x times positive 8 is positive 8x. Negative 3 times x is negative 3x. Negative 3 times positive 8 is negative 24. Let's write the result here. So we have x squared. The middle terms combine. So these actually combine to make 5x and then minus 24. Okay. Down here we have 2x times 3x. So that's 2 times 3 is 6. X times x is x squared. 3 times negative 3 here is negative 9. And we have an x. 2 times 4x, or 2x times 4 is 8x. And then the last one here, 4 times negative 3 is negative 12. Combining like terms here, we have 6x squared. A total of negative 1x, because negative 9 plus 8, and then negative 12. So as far as the patterns go, list all patterns that you recognize. It basically is whatever you see that clicks in your head with this process. How I've mentioned that the like terms combine in the diagonal, that could be something you mention. When you have, let's see, the last two always, the numbers that you have always multiply. So the numbers that don't have x on them, these constants, they always multiply to make the last term of your trinomial, but then they add to make the middle term here. Okay? That's when it's a coefficient of 1. When the coefficient's not 1, it's a little different. The last two numbers do still multiply to make the last term, but when you add them, you're adding multiples of them. Okay, so 3, a multiple of negative 3 is negative 9x. And then a multiple of 4 is 4x and 2x and 4 is 8x. So you're adding multiples of them to make this middle term of negative x. Okay, so that's just some of the things that you might be recognizing. So on the next part, multiply in general. So we're generalizing this process now because there's no numbers. ax plus b times cx plus d, where a, b, c, and d can be any numbers, any integers. Integers are just like the whole numbers, but to include the negatives. Okay, so I'm going to give you a moment. I want you to FOIL this out. Go ahead and push pause in just a second and fill in the box. Alright, so here's our result. I used the box method to do the multiplication, and then I just wrote the result here. And so notice what's going on here. It's saying what kind of patterns do you recognize and any similarities that we've done on previous pages. Well, let's start with the first term and the last term from the resulting polynomial. So the first term is always x squared when we have x times x. And then you combine the coefficients. So it's a times c. So whatever numbers are being multiplied by the x's, they multiply together in the first term to be the coefficient on x squared. In the very last term, it's always these just constant numbers getting multiplied together. But the middle term is what's pretty interesting, because this term in front of, that has the x in it, it's whatever constants you have, in this case b and d. In the last case it was -3 and 4, and the one before it was 8 and -3. It's always those constants, but being multiplied by the coefficients on x. Okay, so notice what you have. You have a combination of the constant b times the coefficient c. You have the constant d times the coefficient a. And so it's always a sum of those values. The last term is always a multiplication, a product of the two constant numbers, and then the middle term in front of with the x in it always is a sum of those coefficients, those numbers. All right, so you can write that in any word you want, or try to summarize it in a way that makes sense to you, and then we will do our last page for this one. Page 13. So factor or factorize the following by filling in the boxes and factor completely. So we are starting with a trinomial. So this is the first time we've actually been required to do this, where we have just 3 terms and we have to figure out, well, how does this factor? So we've been guided along until now. This is like the culmination of all of our work so far. Now what you have to do, and this is what the whole factor by grouping method means, is you have to have enough for groups. And so what I'm saying is, right now you only have 1, 2, 3 terms. You have to have 4 terms to make a group. 2 groups. So 1 term, 2 terms, 3 terms, 4 terms, so that I can have 1 group here and another group here. So we have to think about, well, how do we separate 7x? That's essentially what's happening here. The 2 is still in the back because we multiply to get 2. The 6x squared is still in the front. But how do I break apart 7x in such a way that it's going to help me factor very nicely in this process? Okay, and so if you think about, we can use this box over here, how this is going to work. I'll show you this way with the box, and then I'll show you another way that I tend to write it out. So how do we get a 2? Let's start in the very back. How do we get a 2? The only way to get a 2 by multiplying is a 2 and a 1. So this has to be a 2 and this has to be a 1, or vice versa. Okay, so I'm going to put the 2 here and the 1 here. And I'm just going to put my plus signs to make it very clear they're positive. Okay, so think about how we have to multiply, or what we're going to end up getting to add up to 7x. So now I'm going to have a 2 times some amount of x's. It's going to go in this box. And then 1 times some amount of x's to go in this box, for a total of 7 x's. Okay. At the same time, I have to think, how do I multiply to get 6? So to get 6, I can do 6 and 1. But if I do 6 and 1, just kind of think ahead a little bit. If I put a 6 here, it would end up giving me a 6x times 1. And then if I put a 1 here, I'm going to end up getting a 2 times 1x. That's not 7. I need a total of 7. So let's go with 3 and 2 to make 6. So 3 and 2 to make 6. So let's see if this works out. First of all, if I put the 2 here, I would have to factor further because I'd have a 2x plus a 2, and I'd eventually have to take that 2 out. So I'm going to put the 3 here. So 3x, and so that would mean this has to be a 2x. Let's see if this works. So 3x times 2x is 6x squared. 3x times 1 is 3x. 2x times 2 is 4x. Oh, and that adds up to 7. So this has to be it. So I know the result already. So this is the answer, these on the side here. But let's work it out this way. So we want to break apart 7 in a meaningful way. Okay, so if I break apart 7, let's go with 3 and 4. 7 can be broken down a lot of ways. 1 and 6, 2 and 5, and so on. We're going to go 3 and 4. Okay, so if we plug in a 3 here and a 4 here, let's see what happens. I separate these into groups. So the next step is just me basically having the parentheses around it and saying this is group 1, this is group 2. So group 1, what do these two terms in group 1 have in common? Well, 6 and 3 share a 3, and x squared and x share x. So they share a 3x. So if I factor out, or think of it as dividing out 3x, 6 divided by 3 is 2. X squared divided by x is x. 3x divided by itself is positive 1. Next group, 4x and 2. 4x and 2 have a 2 in common, a positive 2. And so if I factor that out, think of dividing. 4x divided by 2 is 2x. 2 divided by itself is 1. And there's that common factor. This term and this term both share a 2x plus 1, so we factor that out. Remember, we factor out that common factor. That's our last step. So they both, what I underlined, term 1 and term 2 share a 2x plus 1. I take it out. What's left when I take that out is a 3x and a 2, positive 2. And that's the factorization for this trinomial. And that's what we came up with here on the sides of this box. So I know that might not have made a whole lot of sense. It might have seemed like some guessing. So I'm going to show you right now how to not guess, how to know exactly, well, how do I come up with these numbers? We'll do it with this example. So 4x squared minus 13x minus 12. Here's the trick. It's not really a trick, it's a tool. Let me say it like that. Here's the tool. This number here in the front of x squared, we tend to call that a. So in general, we tend to say that this is a times x squared. That's b in front of the x, and that's c in the back. And so a, in our case, is 4. So a is 4. B in this polynomial is negative 13. Let me get my negative sign in there, negative 13. And c is negative 12. And so what you can do here, here's how you know which numbers to use to break this 3-termed polynomial, 3 terms, how to break it into 1, 2, 3, 4 terms. It goes like this. And sometimes people teach this with like an X. I tend to not use that because a lot of students forget what goes on top and bottom. So I'll show you like this. I'll put it in a cloud. Okay, so here's how it goes. You need to find 2 numbers that when you multiply those 2 numbers, you are going to get A times C. Whatever number A is times whatever number C is. And then those same 2 numbers that you find, they must also add up to give you the number B. So this is the factor process for factoring by grouping. This is a really important step. It's so you don't have to guess like 3 and 4, like 2 and 5, how do I get these numbers? This will show us exactly what to use. So let's try it out. So our numbers, 4 and negative 12 are A and C respectively. So I need 2 numbers that multiply to make 4 times negative 12, which if you multiply that out is negative 48. So I need 2 numbers that multiply to make negative 48. And then when I add those numbers, I must get B, and B is negative 13. So this is what I'm looking for. I'm looking for 2 numbers that make this happen. So what are they? And I'm going to give you a list of the numbers that make negative 48 as multiplication goes, and then you can tell me which ones to pick. Okay, so negative 48. It's negative 48 times positive 1. It's negative, let's go with 2 first in the back. It's negative 24 times 2. 3 goes into it if you multiply by negative 16. 4 goes into it if you multiply by negative 12. 5 does not. It doesn't end in a 5 or 0. 6 does go into this if you multiply by negative 8. And that's it. We're starting to get too close. Like if I kept going in my list, 1, 2, 3, 4, I checked 5, 6 worked. I'd go 7. 7 doesn't go into it, but 8 does. I'm repeating numbers at that point. Okay, so think about it. What on my list out of these numbers will also, because we know it multiplies to make 48, negative 48, will also add up to make negative 13. There it is. Did you see it? It has to be those 2. negative 16 times positive 3 multiplies to make negative 48. And then if you take negative 16 plus 3, you will get negative 13. So here's what happens. You take those numbers, and that is the separation you're going to do with the middle term here. Actually, they set it up for us opposite of what I just did, so it doesn't really change anything. There was just already a minus sign on this paper, so let me just put a plus sign. It doesn't matter, to be completely honest, which way you write this. If I would have put the negative 16 here and the 3 here, we will get the same answer. It does not matter which way you do it, you will get the same answer. So what this did is you separated negative 13x so that you now have 4 terms. You had 1, 2, 3 to begin with. You use this process, this whole process, it's actually called the AC method. You use this to go from 1, 2, 3 terms to 1, 2, 3, 4 terms. That is the point of all of this. Once you're here, then you start doing everything we've been working on lately up until this point. So from here, we go back to our regular process. 4x squared minus 16x goes in my first group, and then 3x minus 12 goes in my second group. Okay, so just real fast, making sure you understand this. If you put this back together, negative 16x plus 3x is where we started, negative 13x. We are just splitting 3 terms to make 4 terms so that we can put 2 in one group and 2 in the other group, because we now know how to factor by grouping. So from here, we're good to go. This is grouped. The hard part was the grouping part. How do I group this? We now have 2 groups. Group 1, 4x squared and negative 16x, they share a 4 and an x, these 2 terms. So if I factor out a 4x, if I divide out 4x, the first term is just x. Negative 16x divided by 4x is negative 4. Next group, 3x and negative 12 share a 3, positive 3. And so if I divide that out, I have x, and negative 12 divided by 3 is negative 4. And there it is, my same factor in both groups, or both terms, excuse me. Term 1 before the plus sign, term 2 after the plus sign. I factor out what they share. Both terms have an x minus 4. And so what's left is a 4x plus 3. And so that's my other factor. Okay, we got there. This is the process. So this is called the AC method. And you always do this where you have the number in the front is A, the number in the back is C. You multiply them together. And then you ask yourself, what 2 numbers can I make to get that product? Okay, what 2 numbers can I use to give me that product? Then once you find what you think the numbers are, I gave you a list of possible numbers, you have to answer also this question. Well, do those 2 numbers multiply to make B? Or sorry, add to make B. And if they do, that is how you go from 3 terms to 4 terms. And once you have 4 terms, you can separate into groups and do what we've been doing. All right.